this session, I'd like to look at the indefinite integral and the definite integral of a cubic function. Now we've got x cubed. So let's have a look at the indefinite integral of x cubed, and the variable is with respect to x. Now this will equal, now what do? We take that index 3, we raise it by 1, and we get a 4. And then we divide by that new value of the index. So we divide by 4, and then we put a plus c. Okay, so there is the indefinite integral. That's all we have to do. Now for the definite integral, this time we keep in mind we have to go between -2 and 3. We still raise the index by 1, so 3 goes up to a 4, and we divide it by the new index 4. We don't put plus c. And we're going to go between -2 and +3. Okay, that's finished. Now remember, what we have to do here is we have to substitute 3 into that integral value, then substitute -2 into that integral value and subtract these two. So we get 3 to the power of 4. So we substitute 3. So we've got 3 to the power of 4 over 4. And now we substitute -2, and we've got -2 to the power of 4 over 4. All right, let's have a look at this. 3 3s are 9, 3s are 27, 3s are 81, so we got 81 over 4 minus. Now, -2 to the power of 4 is positive 16 over 4. Okay, so we've got 81 over 4 minus 16 over 4, and we get 60, is that 5 over 4? Okay, 65 over 4, and we simplify that into 4 6s, 24, remainder 1, 16.25. Okay, so we've got a definite integral of 16.25. Okay, so there we have finding the indefinite integral. We have x to the power of 4 over 4 plus c, and the definite integral going between 3 and -2 is 16 1/4. Now, what if we want to use if we want to get the area between the curve and the x, between our curve and the x-axis, between the values of -2 and 3. Well, let's have a look. Will the answer be 16.25? Well, for the last few exercises, remember I had a little note that the function did not cross between our x values. Well, let's have a look at this drawn graph. And here we've got the function x cubed. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. 4 cubed doesn't fit on our graph. -1 cubed is -1, -2 cubed is -8, -3 cubed is -27. Now we are looking for the area underneath the function between the x value of -2 and the x value of 3. Remember those numbers, x is -2 and x is 3. So let's have a look. Let's get the x equals 3 line. That's this line here. Let's get the x equals -2 line. Let's do it properly here. Suppose I could adjust. No, I can't do that. Whoop. again. Draw that line. Okay. So we're talking about this area here. Where's my line gone? Oh dear. All right. Between the function and the x-axis, there we go, there, and in here. All right, so hopefully you can see that. Now, will the area be 16.25? Now, I want you to note well that the function does cross. The function does, in fact, cross the x-axis. And this is what I've been making a point with each session, does cross the x-axis between x equals -2 and x equals 3. So it crosses at x equals 0. All right, so it crosses at x equals 0. So to use our definite integral, what we have to do is break this up into two areas. We've got to go from -2 to 0 of our function, and from 0 to 3 of our function. You see, we cannot use 16.25 as our area, and I'll come to that later. Well, let's do this. We raise the power x to the power of 4 over 4 between -2 and 0. Let's finish this. We substitute a 0, we substitute -2. Now let's change the color. So 0 over -2. We substitute 0. So first let's substitute 0 over 4 is 0. Now substitute -2. -2 the power of 4 is 16. 16 over 4 is 4. Okay, we get a value of -4. Okay, what do we get over here? We raise that integral up from a 3 to a 4. We divide by 4, and we're going to go from 0 to 3. So we have to substitute 3, substitute 0, and subtract these two. So substitute 3. 3 to the power of 4 is 81, and 0 is 0. So we've got 81, and that's 20.25. Okay. Here, we get a value of positive 20.25. Notice the area is above the x-axis, and we've got a positive value. Here we've got -4. Notice the area is below the x-axis, and we've got a negative definite integral. Well, the area happens to be not -4, but positive 4 square units. So we actually have to, because it's going to be a negative, we have to actually consider the absolute value of -4. Can't call the area -4. Area is absolute. It has an area of 4 square units, and above the x-axis over here, it has an area of 20.25 square units. Therefore, our total area between x equals -2 and x equals 3 is add 4 plus 20.425, and you get a total area of 24.25 square units. All right, it is different. How different? Well, do you notice that 20.25 was our value for our definite integral here, and -4 was our value for our definite integral over here. Now, if you add -4 with 20.25, you will get 16.25, and that's where this value comes from. It was 20.25 above the x-axis between 0 and 3. -4 below the x-axis becomes overall 16.25. Notice it's not square units, that's definite integral. Because we have some positive definite integral, we have a negative definite integral that cancels out, and so we end up with overall 16.25 positives. However, the area we've got to consider not the negative, we've got to consider -4 as +4. So we get a different answer. Be careful with using definite integrals and areas. Whilst the maths is related, the answers are not the same.